welcome back to Matt's Playground. Today we'll be solving some problems. I think they're from AMC 8. Alright, before we get to our first question, I have a riddle for you. You have two cups, one of 7 units and one of 3 units, and both of them are unmarked. How do you get 2 units into any one of the cups? And so they start off empty. Okay, so now I guess we have to move on to our first question. 5 different awards are to be given to 3 students. Each student will receive at least 1 award. In how many different ways can the awards be distributed? All right. This seems like a very interesting combinations question. So let's get on with the cases. So, case 1, let's call this no restriction, which is basically the total number of ways. We have 3 to the power 5 because every student can receive an award in 5 different ways. They can each get 1 award, 2, 3, 4, or 5 awards each. So each of the 3 students can receive awards in 5 ways, which gives us 3 to the power 5. Okay, so case 2, I'll try to write a bit smaller because we've got a lot of cases to go on with. At least one student does not receive an award. Does not receive an award. Okay. So this would be 3 times 2 to the power 5, because every award can be given to someone or not, which makes it 2 choices for every one of the 5 awards. And there are 3 students you can choose to go to or not go to. So we have 3 times 2 to the power 5. So now we'll be subtracting this from here because this is the total number of ways, and now we're subtracting the number of ways where it does not follow the restriction. And here's the keyword, at least. Well, keywords because it's 2 words at least. So here is the key part of the case. At least one student does not receive an award. So yeah, and it's also possible that 2 students do not receive an award. All right, so case 3, writing so tiny. At least 2 students do not receive award. All right, I'm a very slow writer. Award. There we go. So only 2 students do not receive an award. We will add 3 because this case was already considered in case 2 here because it was at least 1 student does not receive an award, which also includes the 3 possibilities that at least 2 students do not receive an award, which is 3 ways because it is impossible for none of the students to receive an award, which would have been case 4, but since that is impossible, it is no use to add or subtract 0. So we have a final equation, which is 3 to the power 5, the total number of ways, minus 3 times 2 to the power 5, plus 3, which is equal to 150. There we go. Okay. Second question. A large square region is paved with n squared teal square tiles, each measuring s inches on a side. A border d inches wide surrounds each tile. The figure below shows the case where n is equal to 3. When n is equal to 24, the 576 gray tiles cover 64% of the area of the large square region. What is the ratio d by s for the larger value of n? So when n is equal to 3, one side, the length of one side, is equal to 3s plus 4d, because here we have 1, 2, 3s, and I'm going to change color for the 4d. We have 1, 2, 3, and 4d. So when we have 20, when we have n is equal to 24, then we have 24s plus 25d. So, alright, time for equations. We just gotta get away from equations when it comes to math. And I do love equations. So, 64% it says, right? Yeah, so 64 by 100, which is 64%, times 24s plus 25d whole squared, because that's the area of one whole square when n is equal to 24, is equal to 576s squared, because we're trying to find the area of all of these teal squares when n is equal to 24. All of these, I mean. Alright, so let's square root on both sides. We get 8 by 10 times 24s plus 25g is equal to 24s. So let's simplify this fraction. 4 by 5 times 24s plus 25g is equal to 24s. So now let's multiply by 5 on both sides. We get 4 times 24s plus 25g is equal to 120. Now let's divide by 4. So 24s plus 25d is equal to 30s. Okay. So now it's time for the ratio. Let's take the s to one side. I'm going to skip over here. So 25d is equal to 30 minus 24, which is 6s. So now let's divide by 6s on both sides. We get 25d by 6s is equal to 1. But here's the catch. This isn't our answer because it asks for d by s. If it had asked for 25g by 6s, our answer would have been 1. But we need to find out g by s. So to make this a bit simple, we can write this as 25 by 6 times g by s is equal to 1. So we have to divide both sides by 25 by 6, which gives us that g by s is equal to 1 by 25 by 6. So 1 and 6 multiply, 6 goes up to the numerator, and we get 6 by 25. So that's your answer. All right. Our third question. Find the sum 1 by 2 plus 1 by 2 to the power 2 plus 1 by 2 to the power 3 plus 1 by 2 to the power 4 and so on. So let's call this whole sum x. So x is equal to 1 by 2 plus 1 by 2 to the power 2 plus 1 by 2 to the power 3 plus 1 by 2 to the power 4 plus and so on. Alright, so if we multiply this whole thing by 1 by 2, then we get 1 by 2x is equal to 1 by 2 to the power 2 plus 1 by 2 to the power 3 plus by 2 to the power 4, so on. And this goes on till infinity. And obviously no one can count up till infinity, so yes, so if we subtract x minus 1 by 2x, then the only thing that remains is 1 by 2 because it all went to infinity, both of these. So you never know. So let's go. So we only get 1 by 2 because this is 1 by 2 to the power 2, 1 by 2 to the power 3, and so on. It's going to keep crossing off. So 1 by 2x, this is 1 by 2x, is equal to 1 by 2, which means x is equal to 1. Oh, imagine. Imagine someone takes a few decades to solve this, and they end up with the number 1. That must be sad, wasting almost all their life to just get the number 1. Which is why we have this little thing. Fourth question. Suppose 1at is equal to 2a times 2 to the power a times 3 to the power b times 5 to the power of c, and a, b, and c are integers. Find a plus b. Okay, so let's start by prime factorizing these because 2, 3, and 5 are all prime numbers. So 180, 2, 90, 2, 45, 5, 9, 3, and 3. So we have 2 to the power 2 times 5 to the power 1, 3 to the power 2. So 2 plus 2 plus 1 is equal to 5. There we go. Last question, and then I have to tell you the answer to my riddle. Okay. Last question. How many liters of 80% pure water must be added to 40 liters of 30% pure water to produce 60% of pure water? Okay, so this seems like a pretty interesting question. So, it doesn't say how many liters of 80% pure water we have, so let's call it liters of water. When we have liters of water, we have 0.8 liters of pure water, right? But when we have 40 liters of water, we only get 12 liters of pure water. So let's make an equation. Suppose we add double liters of water to this. So 0.6 times 40 plus W, which is the amount of pure water we get, is equal to 0.8 W plus 12, because since we're adding these two, because this is the amount of pure water, and so is this. So 24 plus 0.6 W, because we multiplied this, is equal to 0.8 W plus 12. All right, now we've got a pretty simple equation. We get 0.2 W is equal to 12. So now let's multiply by 5 on both sides. So we get W, which is equal to 60. So we need 60 liters of 80% pure water to be added to 40 liters of 30% pure water to produce 60% of pure water. Okay. Whew. Okay. Wow, this is a water question, and I asked you a water riddle. Let me say it again. The riddle. You have two cups, one of 7 units and another of 3 units. How do you get 2 units into one of these cups? They're both unmarked and they start off empty. So I'm going to make this a bit bigger. Here's our 7 units cup, and here's our 3 units cup. Let's say we fill this 3 units cup up and pour it into here. Now we've got 3 units of water into the 7 unit cup. Now we fill this up again and we pour it in again. So now we only have space for 1 more unit because we already put 3 and 3 in. So now we fill this up for the last time. Pour this in here. We only fill this 1 unit because if we spill more, then it's going to like fall. So I'm gonna make a very clear picture of this. We started off like this, right? We poured 1 unit into here to make the 7 unit cup full. And then we got 2 units left in this cup. So we did it. See you next time.